Welcome back. I got two more reactions on the topic of oxidation. Each of them are unique in their own way. That's why I kept those two as part of a video and kept the other two because they were both alcohols. I kept them as separate. Now, when an aldehyde goes through oxidation, you see the reagents are exactly the same. And what do they have in common? They all are oxygen rich, so it's oxidation. When you have an aldehyde and an aldehyde undergoes oxidation, it produces an acid. And if you get this question on wrong in my class, I would just give you an F for the course without any consideration, because this is the easiest one. I was just joking. No, I'm not going to give you F because you get this wrong. But if you get this one wrong, so I don't know what else is easier in this world. Okay, this is an aldehyde. You agree, right? 1, 2, 3, 4. Rewrite everybody, including the double bond O, and just add a OH where that carbon containing the double bond O is. That's an acid. How difficult was that? Okay, I'm not going to even bother with it. I just want you to say, name this compound. Again, if you can't do this, I'm not sure what you will do in this course. This is the easiest of the bunch. Next one, an alkene to a diol. What is a diol? Well, let's understand that. This is also part of an oxidation because you see this is changed. Either this reagent or this reagent, osmium tetroxide. Remember that name, osmium tetroxide or tetroxide, or KMnO4. Diol means 2 alcohol. That's what it means. Okay, so when you have an alkene and it reacts with this or this, one of these two reagents, it results in something very unique. It's called a syn addition. Okay, syn means same side addition. Okay. Now I'm going to show you something which again you do not have to memorize, but it will be in one of the choices. We will come back and discuss the purpose of that type of legend later in the course. So rewrite all of these exactly the way it is. Just where the double bond was, you're going to add OH groups, but instead of a bond that you're so used to like this, you're going to use this. Okay, this is called syn addition because these have to do with stereochemistry. Again, you have not learned stereochemistry yet, so we're going to come back and discuss the emphasis of this. Or you can also write it as a broken wedge. This is a solid wedge. The first one I drew is a solid wedge. It's called a wedge bond. Or you can have it as open wedge. But you see in both of these cases are the OH is added to the same side. This is an open wedge and the other one is a solid wedge. But both of these are same answers, okay? There is no real difference between this. But I want you to introduce to the idea of solid and open wedge bonds, as it will become very critical when we learn stereochemistry. All I want you to take away from this is when you have an alkene and you have either KMnO4, which is potassium permanganate, or osmium tetroxide, it results in a syn addition. What is the syn addition? It's a same side addition. That is, we're adding 2 OH groups on the same side. You're not adding them across from each other. And I want you to not name this compound. Let's just leave it be. Okay, this is good enough for this. So I'll see you with reduction, and I think that's kind of where we will complete some of these organic reactions. I know I've already had 23 or 24 odd reactions now, so that's a lot, but stay tuned for more.